Hey, 8th grade. So we've been working on the Pythagorean Theorem all week and last week, and we could continue working on it forever. But now we're going to see how we can find distances in the coordinate plane. Now, obviously, looking at this right here, our first instinct is to be like 1, 2, 3, 4, 5, 6, 7, 8, 9. That's like 9 units apart, right? Well, no, because it's one of those slanty lengths, right? And this right here is not the same length as this part right here. Let me, just blow this up a little bit. There we go. So I'm playing in the Google Drawings, and this is really helpful to kind of outline what I'm looking at here. So we're trying to find the length between these 2 points. And like I said, this length right here is not the same as this length right here. And even if this were like a 1-to-1 correspondence, it wouldn't be the same length. So I said that we can do this using the Pythagorean theorem. This is not a triangle, let alone a right triangle. But we can very easily make it into one. And so let's see what kind of... Okay, there we go. And where's my options on that? I thought I had options. Oh, I guess I have to select it. There we go. Why are you not doing it? Okay, so there it is. I knew I had options. Let's make this orange and let's make it very thick. Okay, so there and here is where we can actually make a right triangle. And so there I did again. So now we have this right triangle, right? And we can determine real quick how big this side is. And so that's 1, 2, 3, 4 units, because we can count horizontally and vertically. That's totally fine. We just can't count on the diagonal. All right, so that's 4 high. I guess let me get my little text box here. So that's 4 high. And then this length over here, oh, dang. Yeah, I'm trying to make this the night before, and I guess my brain is just not working at this hour. Anyway, so this length is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So there we go. So let's bring this back over here, and now I'm going to show you my fancy typing skills. So obviously I wrote a squared plus b squared equals c squared, and now we have this nice, pretty, perfect right triangle. And so we get to use the Pythagorean theorem again. Do we know a and b? Well, yes, this is a and this one's b, and the hypotenuse is going to be c, the slanty side of that triangle. Now, this only works if you are using horizontal and vertical lines here to make this into a right triangle. So many times whenever I have kids do these kinds of problems, they just make wonky triangles off to whatever side, and it's like that's not helping anybody because you still can't count the diagonal. So let's write another equation. 4 squared plus 9 squared equals c squared. And so 4 squared is 16, and 9 squared is 81. And so altogether that is c squared. And I'm going to get my fancy calculator out here so that I can do some quick math without messing everything up. 16 and 81 is going to be 97. So 97 is c squared. And then I want to take the square root of both sides. And so this is where we get really fancy. So the square root of 97 is the same as the square root of c squared. And so that means, sorry, working on my calculator over here. The square root of 97 is about 9.8, and we're just going to round that to 1 decimal place. So this length right here is going to be 9.8 units. So just a little bit more than the straight 9. All right, so there's that one, and now I'm going to go show you, I don't know, another example or two. Dang, it's not scrolling neatly. There we go. So we're going to look at this one, and this one we're going to have to draw our own segment between. So what's the distance between these 2 points is the question. And so we're going to try to determine this length. And now we're going to make it purple because I love purple. And we're still going to make that a fat line. There we go. Okay, so that's the length that we're trying to determine. So last time I went ahead and made the triangle up this way and over that way. Well, this time, I mean, it doesn't really matter, right? I can go down and to the right, I guess. And this is similar to our steps for finding slope, right? Unfortunately, what we're doing here is not finding the rise and the run so much to determine, the pattern in the line. It's determining the actual length, the distance here. And that's going to be keywords in critical questions like this. I mean, I saw questions like this on the SAT, all over the old state tests. But yeah, there we go. So now we're going to put our text box here, and we're going to count because we're good at counting. 1, 2, 3, 4, 5, 6. And we're going to put another text box over here. And it is 1, 2, 3, 4, 5, 6, 7. If I counted properly, which I think I did. Alrighty. My kids are having a hard time going to bed right now, so just hang on a second. Anyway, so what we're going to do here, we are going to save and close this, and then we will see our numbers over here. And again, we are going to do a squared, b squared, c squared. So in this case, it is 6 squared plus 7 squared, again, is the hypotenuse, which is the slanty side, which is the one that we don't know. So 36 plus 49 is c squared. That's the wrong button. Gosh, that's the wrong button. Okay. And then 36 and 49. Gosh, I'm having a hard time right now. 36 and 49. That's 85, and so that's c squared. And then, of course, we want to take the square root of both sides so that we can actually find the distance, because there's no way that if this part is 6 and this part is 7, that the shortcut between them is going to be 85. That's just not happening. It's called a shortcut. So the square root of 85 is the square root of c squared. And so I guess I should probably find the square root of 85, which again is somewhere in the 9s. It's a 9.2 this time, and that's c. All right, there is a third example here, but I mean, honestly, at this point, you should be able to see what we are doing. So a quick recap. You're trying to create a right triangle in which the distance between the 2 points is the hypotenuse, and then you find the vertical distance and the horizontal distances, and those become your A and B in the triangle. And then you determine what C is using the Pythagorean theorem. All right, I'm going to attach a document. It's going to have a whole bunch of points on this one grid, and it's going to ask you to find the distance between any number of points. So it's the same thing. It's just going to be a little bit more, all in the same space. And then tomorrow I actually have a Fortnite map activity. Now, since Fortnite has, become kind of mainstream for teachers, I'm thinking that it's probably not the coolest game, but it was, a couple years ago. But maybe I'm wrong. Maybe it's just really cool and we're finally getting it. But so it's a map on a set of coordinates like this, and then you find the distance between locations, and it's actually using the pictures and map charts stuff from the Fortnite game, I'm assuming. So let me know how that is. I'm going to post that one tomorrow. And so today, what I need you to do is do the one that I attach. Okay. If you have any questions, please make sure that you reach out to me because, like, nobody's talking to me. I miss you guys and it's weird. And my gym closed down, so, like, I have nothing to do. Alright, I'll see you guys tomorrow, and we will do some Fortnite video things. Okay, have a good night.